Okay, dear students, good morning. In this chapter, Trigonometric inverse trigonometric functions, we solved exercise 2.1 and 2.2. The last miscellaneous exercise. I want to complete this one also. Okay, now. After completion of this exercise, that means in this video I want to finish all these problems and the examples before this miscellaneous examples and exercise 2.2. That examples all you have to work out. And altogether, not this week, in the next week you have to write the exam. Please try to understand. It is given to you. Okay. Now you see, find the values of 1 and 2 problems are given. Okay, now the next 3, 4, 5, 6, 7 and 8 are problems we have to prove. Okay. You see, the solutions. Number 1. It is cos inverse cos 13 pi by 6 is there. We have to find the value of this expression. Cos inverse of cos. We may feel that cos inverse cos gets cancelled. 13 pi by 6 is answer. Just like the students will solve the problem. But it is wrong. Why? Because it doesn't belong to the interval 0, pi. Try to understand. In terms of the problem is in terms cos, the interval is 0, pi. If it is in the sine, it is minus pi by 2 plus pi by 2 closed interval. If it is in the tan, it is also minus pi by 2 plus pi by 2 but open interval. Already we solved so many problems. So here it is wrong. Okay now. So which is correct? Now. So cos inverse of cos 13 pi by 6 can be written as cos inverse of cos of 2 pi plus pi by 6. Okay now? Cos inverse cos of LCM is 2, 6, 12 pi plus pi, 13 pi by 6. Now cos of 2 pi plus theta. One rotation is completed and again it is angular first quadrant. So cos of 2 pi plus theta is a first quadrant. In first quadrant all positives. So it is cos pi by 6. So pi by 6 is answer. Cos is here it is cancelled. Why? Because it belongs to the interval 0, pi. Okay now? So this is the answer. Right. Number 2. Let's see. Tan inverse of tan pi by 6. Here also the students may commit the mistake. Tan inverse tan cancels. It is 7 pi by 6. But it doesn't belong to open interval minus pi by 2 plus pi by 2. You have to remember that if the problem is related in the tan, the interval minus pi by 2 plus pi by 2. If it is a cos, 0 pi. If it is a sine, closed interval minus pi by 2 plus pi. Number of times I solved the problem and I have been telling this formula because it is a somewhat a different type of problems. Please note it well. So here 7 pi by 6 means it is pi by 6, 30, 37 is 210 degrees. It exceeds. So it doesn't lie in this one. So this is wrong. Okay now. Then which is correct? Tan inverse tan 7 pi by 6 can be written as tan inverse tan of pi plus pi by 6 6 pi plus pi, 7 pi by 6. Now it is tan inverse tan pi plus theta, tan 180 plus theta, third quadrant, all silver T curves. Tan is positive in the third quadrant, so it is plus tan pi by 6 only. You agree? Yeah. Now it is tan inverse cancels, we get pi by 6. Yes, this belongs to minus pi by 2 plus pi. So this is correct answer. Suppose this is asked in the exam, it is not needed to write this wrong steps. Why? Because for your sake to understand which is wrong, I am explaining this one. You simply follow, this is the solution. Here also it is the solution from here onwards. Not it is necessary to write in the exam. Why? Because for the purpose of to understand which is the wrong. Why? Because the students will commit this type of mistakes. That is why I am expressing this on board. But you have to write the solution like this one. Okay, na? Yeah. Next. Next, we'll go to third problem. From here to 8th problems, these 6 problems are we have to prove, taking LHS, proving RHS or RHS, proving LHS. You see, in order to prove this 2 sine inverse 3 by 5 is equal to tan inverse 24 by 7. Okay, now? Yeah. You see, let sine inverse 3 by 5 be alpha. And simply I am taking, considering sine inverse, not LHS. Sine inverse 3 by 5 is equal to alpha. That implies sine alpha is equal to 3 by 5. Okay, now? Sine inverse comes to this side, sine alpha is equal to 3 by 5. Okay. Then, what about you write the triangle? It is a 3, 5, it is a 4. We know it well. Sine alpha opposite side by hypotenuse. Then adjacent side is a 4 by using the Pythagoras theorem. Right. Then you see it is 2 alpha now. We are assuming this is alpha, 2 alpha. We have to prove tan inverse. So tan inverse comes to this side, it is tan 2 alpha. Therefore, we consider tan 2 alpha. Try to understand. Tan inverse comes to this side, tan, this is alpha, tan 2 alpha. Tan 2 alpha is 2 tan alpha by 1 minus tan square alpha, na? A formula is tan. It is 2 into, what is tan alpha in this triangle? It is 3 by 4 by 1 minus 3 by 4 whole square. It is 2 into 3 by 4 by 1 minus 9 by 16. It is 6 by 4 by 16 minus 9 by 16. Will agree? Okay, now 6 by 4 into 16 by, this 16 comes up. 16 by 16 minus 9 is 7. So at last we get it is 4 fourths. 6 fourths is 24 by 7 is there. This is nothing but tan 2 alpha. Therefore, tan alpha, tan 2 alpha. 2 alpha is tan goes to the side. It is tan inverse 24 by 7. Okay, now? Very clearly. What is alpha? Alpha is this one. So it is 2. Alpha means sine inverse 3 by 5 is nothing but tan inverse. Okay, na? Tan inverse 24 by 7. Okay, na? This is the method. Okay, na? Like this, we may prove. You see here, okay, this is one method. Or another method also we will say directly. What is LHS? 2 sine inverse 3 by 5 is there by taking LHS. But we have to apply one formula. 2 sine inverse x is sine inverse. Right here. It is sine inverse 2x root 1 minus x square. A formula is there. Already we solved in the properties. Completely I explained those formulas. 2 sine inverse x is sine inverse of 2x root 1 minus x square. Like this, it is sine inverse of 2. X is 3 by 5 into root of 1 minus 3 by 5 square. That is 9 by 25. Don't confuse. This is sine inverse of 2 into 3 by 5 into. It is 25 minus 9. 16 by 25 with the root. This is sine inverse of 2 into 3 by 5 into 4 by 5. 2, 3, 6, 6, 4, 24. It is 24 by 25. Okay, now, you see, here also I have to take, it is a side work. Put sine inverse 24 by 25 is alpha. Then what is sine alpha? Sine alpha is 24 by 25. That means it is alpha, it is 24, it is 25. Then automatically the adjacent side is 7. 7, 24, 25 are Pythagoras numbers. 24 square, 576, 7 square, 49, 576 plus 49 is 625, which is 5 square. Pythagoras theorem, using Pythagoras theorem we can. Therefore, what about tan alpha? Tan alpha is 24 by 7. Alpha is equal to tan inverse 24 by 7. We know that alpha is a sine inverse. So sine inverse 24 by 25 is nothing but tan inverse 24 by 7. So we may write it as tan inverse 24 by 7, which is RHS. It is left to you, which is easy to you to learn it. Two methods are there. Okay, now like this. Pass. Okay. Fourth one. Sine inverse 8 by 17 plus sine inverse 3 by 5 is equal to, it is tan inverse of 77 by 36. Okay, now you see, let sine inverse 8 by 17 is equal to alpha. And sine inverse 3 by 5 is equal to beta. It is a simple method. So sine alpha is equal to 8 by 17. Sine beta is equal to 3 by 5. Here is alpha 8, 17. So it is 15. Here, by using the Pythagoras theorem, triangle is 3, 5 means it is 4. Okay, now 64 to 25 is 289 Pythagoras numbers. Right. Now, in the problem itself we have, this is alpha, it is beta. Tan inverse comes to this side, tan of alpha plus beta. So, we have to consider tan of alpha plus beta. It is tan alpha plus tan beta by 1 minus tan alpha tan beta. Tan alpha from this triangle 8 by 15. Tan beta from this triangle 3 by 4 by 1 minus 8 by 15 into 3 by 4. It is LCM 32 plus 45. Okay now? 8 4 32, 15 and 3 is 45 by 1 minus, it is 1 minus means 15 4 60 minus 8 3 is 24 by 15 4 60. Okay now, here also we have to write by 60. Okay now, LCM. So 60 cancels. You may feel that one thing, 4 2's and 3 5's. So 2 by 5 is there, sir. But in order to make calculation is 60 and 60, I do like that one. So this is nothing but 32 plus 45 is 77 by 60 minus 24 is how much? 60 minus 24 is 36. Okay now? So this is tan of alpha plus beta. So alpha plus beta is nothing but tan goes to that side is a tan inverse 77 by 36. You see, what is alpha? Alpha is sine inverse that one 8 by 7 plus beta. Beta is sine inverse how much? 3 by 5. Then it is equal to tan inverse, you see 77 by 36. Okay now? Yeah, it is a problem. Here one more thing. Here also I want to solve in the second method. You see, or otherwise we may solve in the second method. You see, what is LHS? It is sine inverse 8 by 70 plus sine inverse 3 by 5. One formula is there. Sine inverse x plus sine inverse y. It is sine inverse of x root 1 minus y square plus y root 1 minus x square formula is there. So like this, it is sine inverse. X is 8 by 17 root 1 minus y square 3 by 5 square is this one, and plus y is 3 by 5 root 1 minus 8 square is 64 by 289. Okay now, like this. It is sine inverse 8 by 17 into it is 4 by 5. 3 by 5 into it is 15 by 17. Okay, here also we can find the RHS here also the same way. You see 17 5 is how much? 85. This is 32 plus 45. It is a sine inverse 77 by 85. Okay now? You see, put sine inverse 77 by 85 is some alpha. Okay now? So sine alpha is equal to 77 by 85. Write a diagram triangle. It is 77, 85. It is automatically 36 by using the Pythagoras theorem. Okay now, like this. Now we find tan alpha. Tan alpha is 77 by 36. Alpha is tan inverse 77 by 36. Okay, what is alpha? Sine inverse 77 by 85 is nothing but tan inverse 77 by 36. So we can write it as tan inverse 77 by 36 also. That is nothing but RHS. Okay now? Like this we can also prove it. Whatever it may be the method, you have to follow. Okay? Okay. Fifth problem. Cos inverse 4 by 5, cos inverse 12 by 13 is cos inverse 33 by 65. Okay now? Right. LHS, directly I want to take one method. LHS is cos inverse 4 by 5, cos inverse 12 by 13. It is cos inverse x plus cos inverse y is cos inverse of xy minus root 1 minus x square root 1 minus y square. So like that it is cos inverse of xy means 4 by 5, 12 by 13. This is x and this is y. Minus root 1 minus 16 by 25, root 1 minus 144 by 169. X square, 4 by 5 square, 16 by 25. And 12 by 13 square is 144 by 169. It is cos inverse 48 by 65 minus this is 3 by 5 and it is 13 25 5 by 13. Okay now? So it is cos inverse 48 minus this is 15 by 65. It is cos inverse 33 by 65. Okay now? Directly we prove. Okay now? Easily it is solved. It is RHS. Now you see the sixth and seventh problems given to us homework. You solve those two problems by using the second method or first method, whatever it may be. It's left to you. And the eighth one, LHS is directly I am taking the eighth one. It is tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8. It is tan inverse of first I am considering this first two and this two one. Tan inverse x plus tan inverse y. Tan inverse of x plus y by 1 minus xy. A formula is there. Here also tan inverse here it is x plus y by 1 minus xy. Okay now? A formula is there. I am telling you. Tan inverse x plus tan inverse y is nothing but tan inverse of x plus y by 1 minus xy. The condition also is there, but not necessary. You simply apply this one. Okay, now? See, by using that formula, we get that one, and tan inverse. It is 7 plus 5 by 35 by, here also, 35 minus 1 by 35. So 35 cancel. Here also tan inverse of 8 plus 3 by 24 by 24 minus 1 by 24. Okay now? LCM. So here remained tan inverse 12 by 34 plus tan inverse 11 by 23. Okay now? 23. 8, 3 is 24 minus 1. 24 minus 1 is 23. 24 cancel. 8 plus 3 is 11. Again we are getting the same formula. Tan inverse x plus tan inverse y. It is tan inverse of, you see, 12 by 34 and 11 by 23 by 1 minus 12 by 34 into 11 by 23. It is the tan inverse of, you multiply 23 12s, 36, 12 3, 12 2 24, 27, and 11 34, 11 is 34, 4 7 6. Okay now? 12 3 is 36, 6 3, 12 2 is 24, 3, 27. So this is 276 plus 374 by, that automatically cancels. Here it is 34 into 23. It is 212, 90, not 2, and this is 68. It is 287, and 12 11. 12 11 is 132. You subtract 132. It is 0, 5, 6, 650. Okay now? You see, it is the tan inverse of same. It is also 650 by 650 will come. So it is the tan inverse 1. Okay now? Tan inverse 1. You see, this tan inverse 1 is nothing but tan inverse of 1 means tan pi by 4. Tan inverse cancels, we get pi by 4. Okay now? That is we have to prove pi by 4 in this 8th problem. Okay now? Like this we have to solve. But the calculation is more. Be careful. Okay now? Yeah. First. Okay. Next, 9th problem. Solution. Here the problem is tan inverse root x. It is 1 by 2 cos inverse 1 minus x by 1 plus x you have to prove. The conditions you leave out. Here also some condition is there. Not needed. In the problems it is not needed. If we are specifically asked there, we have to prove. But here not. In the properties only we have to prove. So here we prove this one. You see, put x is equal to tan square theta. That implies root x is equal to tan theta. That implies theta is equal to tan inverse root x. Okay, na? Theta is equal to tan inverse root x. Okay, na? Right. Now, you see, I'm taking that one, RHS. What is RHS? 1 by 2. It is cos inverse 1 minus x by 1 plus x is there. This assumption must be there. It is nothing but 1 by 2 cos inverse. It is 1 minus tan square theta by 1 plus tan square theta. Okay, now it is 1 by 2 cos inverse 1 minus tan square theta by 1 plus tan square theta is nothing but cos 2 theta. A formula is there in the compound angle. Cos 2 theta. Cos 2 theta. Cos 2 theta is cos square theta minus sin square theta. One formula. 1 minus 2 sin square theta is there. 2 cos square theta minus 1 is there. And this fourth formula is also there. So here it is 1 by 2. Cos inverse cos cancels. We get 2 theta. So it is theta. Okay, now. So what is this? Okay. Theta is nothing but, you see here in our assumption, it is tan inverse root x. Okay, now that is nothing but LHS. Okay, now we are taking RHS and we prove that LHS, tan inverse root x. But this is the assumption, it must be taken. Now, now, 10th box. It is cot inverse root 1 plus sin x plus root of 1 minus sin x by root of 1 plus sin x. And it is minus root of 1 minus sin x. It is LHS we are considering. It is nothing but cot inverse of. You see, the sign we have to work out 1 plus sin x or 1 minus sin x. The root of 1 is cos square x by 2 and plus sin square x by 2. Will agree? Okay, now 1 cos square theta plus sin square theta plus sin x is 2 sin x by 2 cos x by 2 na a square plus b square plus 2ab sin theta is 2 sin theta by 2 cos theta, like that. It is root of cos x by 2 plus sin x by 2 with root 2 square cancels. We get cos x by 2 plus it is sin x by 2. If it is minus, we get a minus. Here minus 2 whole square root square cancel. Here we get a minus. So like that it is cos x by 2 plus sin x by 2 plus cos x by 2 minus sin x by 2 because minus is there. And by it is also cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2. Okay, now it is cot inverse of sin x by 2 cancels. Cos x by 2 cancels. Cos plus cos 2 cos x by 2 by sin minus of minus plus sin 2 sin x by 2. 2 cancels. We get cot inverse. This is cot inverse. It is cot inverse of cos by sin is cot x by 2. Okay, now? So we get x by 2. Okay, now? This is nothing but RHS. Like this, I have to prove. Like observe. 11th one. It is tan inverse of root 1 plus x minus root 1 minus x by root 1 plus x plus root 1 minus x square. Here the problem is with ratios, but here it is not ratio is not there, not sine or cos is not there. So we have to assume something. Okay, now you see, put x is equal to cos 2 theta. How can we take cos 2 theta, sir? If you take sin 2 theta means, if you take sin 2 theta, it will not come. Cos 2 theta, 1 plus cos 2 theta, 1 plus cos 2 theta, 1 minus cos 2 theta, formula is there. And here it is cos inverse x is equal to 2 theta. Theta is equal to 1 by 2 cos inverse x. This is our assumption related to the problem. Yeah, okay. Now see, it is tan inverse, it is root 1 plus cos 2 theta. Root of 1 minus cos 2 theta by root 1 plus cos 2 theta plus root 1 minus cos 2 theta. It is tan inverse root 1 plus cos 2 theta. It is root 2 cos theta. Formula is there. 1 plus cos 2 theta is 2 cos square theta. With the root is there. 2 cos square theta, root. The root 2 cos theta. Square root cancels. Here also 1 minus cos 2 theta. 2 sin square theta. Root 2 sin square theta. Root 2. Here it is root 2. We get the sin theta. Similarly, here also root 2 cos theta. Plus root 2. It is sin theta. Root 2 if taken common cancels, we get it is tan inverse. Okay, now tan inverse. It is cos theta minus sin theta by cos theta plus sin theta is there. Yeah. Now you see. Observe. Here, observe. It is tan inverse of. It is tan inverse of. I am taking cos as common. Actually, formula is everything is given in the theory. Cos theta minus sin theta by cos theta plus theta. If you divide with the cos theta, we get 1 minus. This is tan theta by 1 plus tan theta. This type of problems we solve. If you divide with the cos theta, numerator and denominator, cos cancels 1. Minus sin by cos is tan. Here also cos cancels 1 plus sin by cos is tan. And it is, you see, it is tan inverse of 1 means tan pi by 4. Or otherwise I will write it as pi by 4 minus theta. You see, tan pi by 4 minus tan of A minus B, tan A, tan pi by 4 1 minus tan B, tan theta by 1 plus 1 into tan theta. Tan pi by 4 1 tan theta. So tan and tan cancels, we get pi by 4 minus theta. What is theta? There theta is 1 by 2 cos inverse x. Okay, Nana? So that is RHS. We are considering the LHS and we proved that 1 by 4, 1 by 2 cos inverse x. Here you mentioned it as LHS. Okay now? That is the problem. Yeah, pass. Yeah. Next 12th problem. 9 pi by 8 minus 9 by 4 sin inverse 1 by 3. Oh, I have to prove that one. It is the LHS. Okay, now I am taking LHS one in that 12th problem. 9 by 4 is common. Okay, now? So here it is pi by 9 pi 4 to 8 minus it is a sin inverse 1 by 3. Okay, now 9 by 4. You see here pi by 2 minus sin inverse. How can we reduce? A fantastic concept is that you see we know sin inverse 1 by 3 plus cos inverse 1 by 3 is equal to pi by 2 now. That is property is there. Sin inverse x plus cos inverse x is equal to pi by 2. So here it is cos inverse 1 by 3 is nothing but pi by 2 minus sin inverse 1 by 2. Will agree? So by using this concept, you see, it is simply cos inverse 1. So it is 9 by 4. This cos inverse 1 by 3, again it is changed. You see, cos inverse 1 by 3, let it be alpha. Then cos alpha is 1 by 3. That is using the diagram alpha, the triangle. Cos alpha is the adjacent side. It is hypotenuse. It is 2 root 2. That means 9 minus 1 with root. Root 8 means 2 root 2 we will get. Okay now? So what is sin alpha? Sin alpha is 2 root 2 by 3. Okay now? Alpha is sin inverse 2 root 2 by 3 we will get. Okay now? Like this, if it is not clear, I will tell it here. You see, if it is not clear, I will tell it. You see, sin alpha is 2 root 2 by 3 now, opposite side by hypotenuse. Alpha is sin inverse 2 root 2 by 3. Alpha is nothing but alpha cos inverse 1 by 3 is nothing but sin inverse 2 root 2 by 3. Okay na? Instead of writing cos inverse 1 by 3, it is sin inverse 2 root 2 by 3. So I am writing here it is sin inverse 2 root 2 by 3. Okay na? So it is RHS. Okay na? Is it clear? It is important problem. These problems are important. Try to learn it. Okay. Pass. Yeah. Here 13, 14 are the problems from which the condition will find the value of x. Solvation for these two problems 13 and 14. Whereas 15, 16, 17 are the objective type questions. Okay. Now I am taking the 13th question. Where given, condition is given, not it is proving. It is a condition. 2 tan inverse of cos x is equal to tan inverse 2 cosecant x. I am using this formula. We know that 2 tan inverse alpha is a tan inverse of 2 alpha by 1 minus alpha square is a property is there. So like that here alpha means cos x. So it is it can be written as tan inverse of 2 cos x by 1 minus cos square x is tan inverse 2 cosecant x as it is. Here it is tan inverse 2 cos x by it is sine square x is equal to tan inverse 2 cosecant x. Okay, now you see it is the tan inverse 2 cos by 1 sine is cot x and 1 by sine is cosecant x. Okay, now we agree? 2 as it is 2. Cos by sine square is there, cos by 1 sine is cot and there remains sine in denominator, so 1 by sine is cosecant x. Here in RHS it is tan inverse 2 cosecant x as it is. So tan inverse cancels and 2 cosecant cancels. We get at last, you see, there remained cot x is equal to, here it is 1 or otherwise I will tell you. It is 2 cot x, cosecant x is 2 cosecant x. Cosecant x, 2 cancel. So we get cot x is equal to 1. 1 means cot 5 by 4. So x is equal to 5 by 4. So okay now, that is the value of that one. Now, see.